Yes, but it's times 10 to negative 7.
Oh, okay.
Which is basically saying 0.
Okay.
Very good. Other questions for me? Other questions? I'm sorry? I have to go back to word problems, and then if we have time, we will. Okay, so let's look at, did we do the problem with sugar? Or we didn't do any word problems last time. You want to do the problem with a medicine injected in a bloodstream of a patient, or you want to look at somebody who's taking sugar? Because I would like you to see applications of this. Let's do the 102. Because I want you to see the reason why we look at these functions, and at least one application. So a drug is injected into a patient, and the concentration of the drug in the bloodstream is monitored. The drug's concentration C of t, C concentration T time, so it's in milligrams per liter, after T hours, T time in hours, is modeled by the following function: 5t divided by t squared plus 1. Okay. Before I read the first question, can you please tell me what type of function is this? Yes, it is type 2. How do I know that it's type 2? The degree at the bottom is bigger than the degree of the top. What is the horizontal asymptote of type 2? Awesome. Which I hope that when I get a medicine, eventually, the concentration of medicine in my bloodstream approaches 0. I hope so. Otherwise, it will stay in my system forever. Okay?
I don't think you've ever been on morphine.
Okay. We have to do something about it. So part A, they are giving us the graph. So let's look. I would like to graph it. They are giving us the graph, and they want us to graph it on 0, 10, 1. I'll explain what that means. By 0, 3, 1. What does that mean? Of course, time. I don't care for the negative side of time, right? 0 to 10 with a scale of exactly. And I want 0 to 3 with a scale of, let's do it. By the way, let's look at this function and please tell me if it has vertical asymptotes. What happens to x squared plus 1 or t squared plus 1? Exactly. It's always positive. T squared, you can plug in anything. You have to plug in a positive number anyway. But even if you plug in a negative number, this will be positive. Plus 1 will be positive. So never 0. When the denominator of a rational function is never 0, does it have a vertical asymptote? Does it have a hole in the graph? No. Very good. So in y equals, clear? Clear everything? Do I need to put a horizontal asymptote for type 2? No, because it's the x-axis. Very good, awesome.
And that's always.
Always for type 2, always. So in parentheses, 5x divided by x squared plus 1. There is no t in the calculator. So the viewing window, as they wanted us to use it, as 0 to 10 with a scale of 1, and 0 to 3 with a scale of 1. And let's graph. Ah! Where does it go? This is only 10 hours. Well, where does this go? Closer and closer, closer and closer to 0. Okay. Perfect. So we graphed it. Now here's part B. Use the functions equation. Oh, part A, I'm sorry. Use the graph to obtain a reasonable estimate of the drug's concentration after 3 hours. One, 2, 3 hours. What is the concentration roughly? Yes, I would say that. 1.5 milligrams per liter. Yes. From the graph, part A, T equals 3 hours. It appears that C of 3 from the graph is approximately 1.5 milligrams per liter. Part B. Use the functions equation displayed in the voice balloons. By the way, a lot of effort, collective effort, was put into this function. A lot of patients were tested. A lot of doctors were involved. A lot of mathematicians were involved to come up with this function saying to us, hey, this models the concentration in the bloodstream of a patient if you use such and such medicine. This is not easy to come up with. Okay? So, they want us now to determine, use the functions equation displayed in the voice balloon, blah, 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 by the graph, the concentration after 3 hours. So here's what I do. I go to second and table. Oh, yes, of course, I keep forgetting. I have to go back to second and table set. Sorry about that. So second and table. And I plug in 3. And what should I get? If our estimate from the graph is pretty good, and if the model is good, what should I get? Yes, close, right? I don't know. We haven't looked at it's 1.5. Okay, so part C. Use the functions equation to find the horizontal asymptote for the graph. I don't need to look at the graph. I know it's type 2. Describe what this means about the drug's concentration in the patient's bloodstream as time increases. We already said that. As time increases, we expect the concentration to get closer and closer to 0. Some radioactive substances from different tests may never go completely to 0. Okay? We don't know, really. Good, so that was an illustration of a rational function type 2 with a horizontal asymptote 0. In other words, y equals 0 horizontal asymptote. And we determined C of 3 to be 1.5, indeed using the function, milligrams per liter. Okay, I would like to review polynomial and rational inequalities. Ready? Let's say 24 on page 441. Negative x squared plus 2x greater than or equal to 0. What type of inequality is this? Awesome. Specifically, awesome. Specifically, what type? Which type of polynomial I'm asking? Say it again. Type of polynomial. Type of polynomial. What type of polynomial is this? It is a polynomial, but this is a type of polynomial that we know everything about. It's quadratic because the degree is 2, correct? So this is a binomial inequality, specifically quadratic inequality. We agree? Perfect. What do you think we should do first? Yes, that's the key. But first, if you remember, I said I refuse to solve anything with a negative leading coefficient. So I will multiply both sides by -1. What is left? Very good, awesome. Do you have to do this? Do you have to eliminate the leading coefficient if it's negative? I highly recommend it. Will you get the same answer if you don't? Yes. But it's always easier if you do. Good. What now? Reese already told us factor. How do I factor this? Yes. Awesome. Thank you. What is left in parentheses? Very good. Now, how do we solve quadratic inequalities or binomial inequalities? Let me refresh your memory. We use a chart. Now, in that chart, I will have how many different factors? Well, it depends on how many factors I have in here. How many different factors? Shannon? 2. Very good. So x is the variable in the problem, but then the first factor is x. The second factor is x minus 2. And what will the last row consist of? Exactly, the whole thing. Not both of them, but their product. Okay. Now, here's a very important question. Is that inequality chart ready? There are 2 conditions for the chart. I cannot just put stuff in the chart. There are 2 conditions for the chart. What is the first condition? So one side has to be a product or a ratio. That's one condition. What is the other condition? The other side must be 0. So I cannot, this means nothing. If I don't have 0 on one side and a product or a ratio of factors on the other, I cannot use this. If this is 5, this has no meaning. If the left-hand side is not factored, I cannot put anything in there. Because I'm going to discuss product or ratio to find the sign. So one side must be 0, on the other side must be a product or a ratio. Perfect. What do I determine next? Where is this factor? What?
0.
Awesome. Where is this factor 0? When x is?
0.
Of course. Where is this factor 0? Very good. Now I have the 2 important numbers that I need to put in the chart that they have to be in ascending order. So first I put, and then, awesome. In the row for x, there must be a 0 somewhere. Where? Under which number? In the row for x minus 2, there must be under 2. What happens to the entire product when x is 0? Of course, when one of the 2 factors is 0, the product will be 0. Correct. What happens under 2 for the product? 0. Now I have to analyze what I always analyze with x and x minus 2. If their slope, because they're linear functions, each individual portion, right? If the slope is positive, they come from negative, they cross the x-axis, and they go to positive. If their slope is negative, then they come from positive, they cross the x-axis and go to negative. Both of them have what? Positive slope, so they will follow which sequence of signs? Negative to positive. So they are negative before they cross the x-axis where they are 0, and then positive beyond the x-axis. So I see 3 subintervals. Sign on the first one. Remember, we are multiplying those factors. If we don't multiply them, I cannot use the chart. Indeed. In the middle, And outside. Awesome. Only now I am ready to look here. This tells me what to pick. What is less than or equal to 0? Which sign is less than or equal to 0? Negative. Now I don't care about any of this. I'm only looking here. Is this expression ever negative? For which x values? So solution is x in the interval. Exactly. Thank you. Very well done. Any questions? I would like to choose a rational one. Let's say 54, in which we have x plus 3, x minus 2 over x plus 1 less than or equal to 0. So we're given this inequality. What type is it? Rational. How many factors? I'm happy because it's already factored. How many factors we have? Is this inequality chart ready? Because if it's not ready, I cannot use the chart. One side is 0, and the other side is a product or a ratio of factors. So it's chart ready. So I'm going to start the chart then. What is the first row in the chart? X values is always the first one because I needed space to put those numbers in. The next row in the chart. Very good, awesome. Next row in the chart. Very good. And the last row in the chart. Because I don't have enough room, I'm going to just write ratio. I can do that if I want to. How many numbers will I put in the chart? Good. And please give them to me in ascending order. Yes? Yes? Awesome. Indeed. -3 from here, -1 from here, and 2 from here. Awesome. That's all we need. -3, -1, and 2. Where is the 0 for x plus 3? Where is the 0 for x minus 2? And where is the 0 for x minus 1? Good. Now I have to be super careful. What happens to the ratio when x is -3? Indeed 0, because the top is 0. What happens to the ratio when x is -1? Very good. What happens to the ratio when x is 2? Awesome. So now I would like to know.
Wait, what did it
Is that okay? Is that clear? Is that a yes?
So basically, with a rational number, there's always an undefined number. Or
Yes. When the denominator is 0, yes. Is that okay? Perfect. So what is the sign of all these three? Negative to positive indeed. Leading coefficient is positive. In other words, the slope is positive. They are going from negative values to positive values. I need the sign when I multiply or divide three negatives. Three negatives. In the middle, I have two negatives. In the next, I have one negative. And in the last one, no negatives. Good. Only now, I'm asking myself, okay, what does this want me to choose? What does the inequality want me to choose? Negative. So the ratio is negative in two different situations. So x in the interval, negative infinity, comma, negative 3, parenthesis or bracket. Very good, because it can be 0. Awesome. Union, comma, okay. Which one? Yes, I cannot include negative 1. It's undefined, and the bracket at 2. Very good. Perfect.
Could you go over why the inequality wants you to choose negative again?
Because it's less than or equal to 0.
Oh, I see. So you just use that to determine whether it's a negative.
Yes. So I need to find x such that this expression is less than or equal to 0. This expression less than or equal to 0 means must be negative, so it's less than or equal to 0. Very good. Okay, so what would you like to continue with? Type 3, another type 3. Okay. So let me make one up. So let's say f of x equals x cubed. I'm going to say negative x cubed. Plus 1 over x squared minus 1. Okay. What is the first step we have to perform right away? Yes, awesome. And I don't like a negative leading coefficient, so I'm going to put negative in front. And I will factor the denominator. How do I factor a denominator? Yes? I cannot factor out x. It's 1. Very good. It's our agreement. Difference of squares. And since I'm pulling out a negative 1 from the top, what is left for now? I'm pulling out the negative 1, nothing else. I cannot factor out anything else but negative 1. Very good. Awesome. By the way, is this type 3? Yes? Very good. Now I have to remember how to factor the top. If I don't remember how to factor the top, I'll have difficulties. This is the difference of, good, which it means we are going to give me a binomial times the trinomial. Awesome. Very good. Well done. What is the binomial? X minus 1 indeed. The trinomial has everything in there except the 2 in the middle. It has to be plus. If this is minus, this is minus, this is plus. Plus x plus 1. Very good. Okay, after all this work, what will I do next? Very good. Can anyone give us a domain? After you look carefully, not before.
Oh, that's a negative. I thought they were both positive.
Negative 1.
Yes? And? Okay, that's it. Everything excluding negative 1 and 1. Now I go back to the graph, to the function, and I am allowed now to do something to it. Not before I stated the restrictions or the domain. What am I allowed to do to this function now? Say it again. Exactly. So what will I write about x equals -1 and what will I write about x equals 1? I'm going to copy the simplified form. And now please identify what happens at -1 and what happens at 1. Yes? Say it again. Because it stays and I cannot get rid of it. Yes. So x equals -1 is what? Very good. And x equals 1, because x minus 1 went away, x equals 1 is not a vertical asymptote, but what do I have to write left and right here? What do I have to write left and right here? Careful how I do this. I must plug in 1 in this function, in the simplified form. Plug in 1 and tell me what you get. 1, no. 1 plus 1 plus 1 over 1 plus 1. Yes? The open point will be 1 comma -3/2. Good. So please plug in 0. Very good. X squared plus x plus 1 is not factorable. It doesn't have solutions, real solutions. So there are no x-intercepts. I have to use -1.1 and -0.9 to determine the sign here. This is always a positive number. How do I know? It's because it's coming from a difference of cubes and it has degree 2. This will always be a positive number. So let's plug in -1.1. -1.1 plus 1 with minus in front. Awesome. -0.9 plus 1 with a negative in front. What is the very last thing that I need to determine for this function? And I'm done. Yes, which in this case will follow slant asymptote. Awesome. Yes. Great. So how do I get the slant asymptote? Yes, let's divide. X squared plus x plus 1 over x plus 1. Oh yes, of course. What goes in the box? Very good. So then 1, 1, 1. Bring down 1, -1, then 0, and then 0, and the remainder is 1. It appears that the slant asymptote is x. Now, be very careful, because I did not take this into account, right? I should have written -1, -1, -1. So it will be -x. Or we go back and correct this one. So I can divide, and when I'm done dividing, I distribute -1. Or when I do the synthetic division, I have to write -1, -1, -1. And then I get the same thing.
So the slight asymptote is negative if your remainder.
What? No, not the remainder. Not the remainder is negative.
So
We had a minus in front.
no, I'm saying in general. So what makes the asymptote y equals x versus y equals negative?
The coefficient is negative at the top.
Okay.
So y equals -x, slant asymptote. y equals negative x, slant asymptote. Since the slant asymptote now, does it look like this? Or does it look like this? Like this, which means the end behavior is positive infinity or negative infinity. I'm trying to make sense of the information. I'm not sure till I look at it and I try to slowly try to understand it. The slant asymptote is this. So the function is coming from positive infinity, and on the left-hand side of the vertical asymptote, it goes back to positive infinity. So very possible. From approaching this slant asymptote to approaching the vertical asymptote. Okay. Here, from negative infinity, it crosses the y-axis at 0, -1. It goes through an open point at 1, -1.5. I don't know where it turns, because it has to turn and go to negative infinity, because that's a slant asymptote. So it's coming from negative infinity, does whatever it does, and it has to go back to negative infinity towards the slant asymptote. So on this side, from negative infinity, crossing the y-axis at 0, -1 does not touch the x-axis. Goes through that point, 1, -1.5, and it drops towards negative infinity, approaching the slant asymptote. When I graph a function with asymptotes, what do I have to graph first? Yes, so let's do that. How many asymptotes does this function have? 2. What is the first one? So the first one is not -1, but very good, awesome. And the other slant asymptote is?
Theta.
Yes, very good. Here is negative x. Good. So my chart says this. From approaching the asymptote towards infinity, approaching the vertical asymptote towards infinity. No problem. Here it is. Now here, from negative infinity, we'll cross at 0, -1. At 1, at 1, -1.5, 1, -1.5, there is a hole in the graph, and then approaching negative infinity. No problem. I don't know where it turns, though. It may do this. I don't think it does this. Impossible. But it may do this. I don't know. And I don't have this minimum. So this is the function f of x equals -x³ + 1 over x² - 1. With the graphing calculator. Clear? How many functions do I have to put in? 2 functions, -x³ + 1 divided by x² - 1. And the second function that I have to put in is? Very good. Awesome. Now let's think a little bit about the viewing window. I don't know how high that minimum is. I know that the maximum is somewhere between -2 and 0. So I'm going to say the viewing window between -7 to +5 with a scale of 1. Y minimum, I'm not sure. I'm going to say -4 for now. And Y maximum, I may have to go further up. I don't know. I'm going to say 20 with a scale of 5. Aha! That's it. And I see the blip right here. At 1, -3.5. 1,5. So it's coming from positive infinity, comes to a minimum, goes to positive infinity, from negative infinity. It appears that it turns on the x-y-axis, that's fine. Here there's an open point and approaching the slant asymptote. So I want to find the minimum between -3 and -1.1.
What's your window again?
-751, -425. What is happening here? Okay, ready? So I go to second and calc, and I want to determine the minimum, which is 3. And I know I see it is between -3 and -1.2. -3 is the left bound, and -1.2, I cannot put -1. It's the right bound. I don't want to guess, just give me the minimum. And the minimum is at -2, 3. -2, 3. Okay, on the other side, I want to determine the minimum between -0.9, not the minimum, I meant to write to say the maximum. The maximum, so with 4. And I want -0.9. And I'm going to say this is 1. I'm going to say 0.9. Second and calc. I want the maximum. And I want between -0.9. Yes. That's the right. That's not the right bound. Okay, I see. That's what happened. So 4. I want the left bound. Oh, once I click enter, it just goes directly to. Okay, 4. Okay, the left bound. I want -0.9. Enter. And now the right bound. I'm gonna say 0.9. Okay, good. And enter. I don't want to guess. Okay, so it is that point. It is 0, -1. So this is the local max. Indeed. Any questions for me? Any questions? I have a little work for you today. We have 10 more minutes as we discussed, so. Yes, please.
So on my calculator, when I have 2 lines graph, it only allows me to calculate the depth again.
Let me take a look. Let me take a look. Okay. Yeah, just don't want to make the columns. It's a 2-minute problem, but I don't want you to finish in 2 minutes.
How far you got?
I don't have batteries. You can use the software if you want. I didn't get batteries yet. So what are we going to do? Okay, so then we do this. So second and calc. So we want to find the minimum, right? So the left bound is, so this is around -2, right? So I want -3.4. And it shows me a -2 there. Now I can pass the minimum
Oh, gotcha.
and press enter again, and no guess, enter again, I should get that.
got it, okay, thank you.
Better?